we back?
Should be in just a moment here.
And then we're gonna get another ad right away.
No, I
Probably.
don't think it does. I think it's on timer, right?
Okay, I think we're back.
No, we're still doing
Yeah,
calculus.
no, that's cool. Oh, we are back. Okay, cool. So we had to do a little tinkering there. So, all right, before we turn Adrian loose again, he made a couple of comments that I want to illuminate, expand upon. Coming out of high school, can you complete the square? If
Good
you
one,
can't
yeah.
complete the square, your high school education is not good enough. So,
Geometry.
depending on the calculus you're taking, maybe not in 154, but in the other two, 134 and 144, you better be able to complete the square. And completing the square where the leading coefficient is not a 1. So in other words, oh, don't do it that way, you're just going to confuse people. Quit being high school.
That's why it's called what it's called, though.
Well, I know, but this isn't
I
where we're
just
going.
circled it.
Stop that. If you want to do something, write ax squared plus bx plus c is equal to 0. Anyway, completing the square. You got to be able to do that. Know your trig identities. There's a number of things that you should know. If I was going to tell you to memorize anything, just the first quadrant in the unit circle, because the other three follow from that. You don't need to memorize the whole thing. So there's a number of different topics, but calculus 134 and 144 are going to beat up trigonometry pretty hard. 154 because it's business oriented, not so much with the trig. Everybody else gets a trig. What are you doing?
I'm not listening to you.
That's well, like I'm used to that. Okay, let me reach over there and yank the cord. So review your high school stuff, specifically for the more complicated manipulations of algebraic expressions. Not everything's going to be polynomials. I'll tell you right now, in 154 calculus, the business-oriented calculus, logarithms and exponential functions dominate. You are going to
All
be
polynomials.
really
Infinity.
deep into logarithms when you do that. 144 is going to have trig, logs, exponentials, because science lives on that stuff. So does 134. But I wanted to say for 134, for the biological sciences, I haven't seen what they're planning to do this semester just yet.
I've
But I
taught
can
it
tell
once
you
or
from
twice.
previous semesters, you're going to have to learn how to do cobwebbing. Okay, so finding optimal points. So I would strongly suggest you use, well, you can find whatever tools you want online, but I always point students towards GeoGebra, which usually, I think it's GeoGebra, now that I think about it. Yeah, it is GeoGebra, because there's an app to help you learn how to do cobwebbing. So that's a couple of topics, and differential equations are going to fit in there too for population studies. What's going on behind me over here? There we go. That's it. Now you're talking. There we go. That's
To the line, to the curve, to the line, to the curve, to the line, to the curve.
Now, what's really interesting in business, as you're doing
Equilibrium.
on the screen too,
Equilibrium.
one of the topics the business faculty is going to teach you at the end is called the Lorenz curve, which follows from this, because you've got a 45-degree line going like this. Here's 0, here's 1. So this is the Gini index for what is the equitable distribution of wealth. So what you have is a polynomial. And how big this area, or pardon me, not that area, sorry. How big this area is what you're interested in. Anyway, this is coming up. So there's lots of topics.
And we also do have a playlist on YouTube under the tutor wizard that's things you should already know. We should probably flesh that out a little bit, but those will be, that's what we wanted was the high school things like completion of squares and all this algebra and absolute values and stuff. Things you should already know.
Okay. All right, so that's for calculus. Calculus is going to tax your algebra skills, and it's going to be merciless. Now, I haven't seen all the details yet, but with the advent of ChatGPT, I believe what they're going to be doing, they being faculties in charge, or the course captains in charge of the various calculus streams, is they've reduced the number of written response questions that you're going to hand in because they fully expect all students to use ChatGPT, so now it's basically, that would be free marks.
Oh.
And some discussion has been to replace those with in-class quizzes.
That's
If you're
not
thinking
symmetric.
ChatGPT is gonna give you an easy 15 percentage point bump,
I gotta
ain't
chime in
happening.
with this though after
No.
Adrian chimes in.
Yeah, go ahead.
And then brace yourselves. If you've never done this and you're genuinely doing this, and hopefully we can get you for each year coming out of this. I disagree with the slog of the education thing
Oh,
that's about
this
to
is
happen
some
to you.
philosophy.
They're gonna do pre-class quizzes, and then they're gonna have a pre-class video, and then a
That's a
fucking
little-
post-class, and this is just like, there's gonna be so much. So brace yourself. Brace your freaking
on the whole topic of
I'm behind
ChatGPT, as a grader, as a frequent grader for professors whom we won't
We
mention,
can tell. We can tell.
it's getting increasingly easier to tell which students use ChatGPT.
Yeah.
But here's the thing. All ChatGPT has done is made tutoring more accessible to everyone because it was very cost prohibitive before.
Yeah.
But now because everyone can have a personal tutor
Yeah.
through ChatGPT and the like, Gemini, Grok, whatever, right? Now because everyone can do that, no one gets that competitive edge anymore.
No.
And so that's why, so I don't even know, like,
My caring is directly proportional to your caring.
Yeah, that's another
You're
way to-
cheating yourself if
Yeah.
you're
That's
using ChatGPT.
Lorenzo's the
You're not-
disembodied voice, by the
Yeah,
way.
you're not cheating me though in the class. I don't care whether you use ChatGPT really to answer the question. I care whether you're becoming a smarter individual. If you're just going to go around the process
Yeah.
and just try to jump through hoops and use ChatGPT, good. But you're just fooling yourself, not me. We
Okay.
can tell.
All right, since we're talking about calculus and
brace
we're
yourself,
talking
there's gonna be a lot
about
of questions.
ChatGPT,
Questions.
I think, and since we're already, what's the word I'm looking for? We're already encroaching onto the business of the how hard can it possibly be topics. If you're an engineering student, Math 100 is going to be a really
Really
big
freaky
wake-up
hard.
call. Not only the questions are going to have some substantial teeth to them, they're going to be marked hard.
And if it feels like
You're-
they're trying to make you tap out, they are trying to
Yeah.
make you tap out.
Okay, so
if you're in engineering, come to us,
Facts.
in
Okay.
short.
They're
Now-
using the math department as the bad guys
Well,
to
now,
separate
hang
the
on,
wheat
hang
from
on.
the chaff.
Okay,
Facts.
philosophy, stop. Math, start. First
Is there a
semester
difference
calculus in engineering is already going to be hard enough, but if you're in the Faculty of Science, you get 4 semesters to do the whole Stewart calculus textbook, all 1,300 pages of it.
Do we have an ad?
Oh,
Do
we
you want to
do,
respond
okay.
to Mean Machine Rex there?
Oh, where are we at right now?
We're-
We are in a study room. Our usual room I normally use here at the university is closed for...
We have an ad.
We do?
Tapey.
I have an
No,
ad.
I don't have an
Tippy
ad.
typey.
Oh, I have an ad.
No, I don't.
Oh.
Doesn't matter. Who knows? Twitch is doing stuff.
I don't
Anyway,
know how
to
to
add
use any
we're
of
just
the
in a
internet.
different room where I can access.
He
today.
does felt on board.
They said show up, and so I brought a book.
you still
what's
running an
a
ad?
book, Precious?
No, I'm.
You're done with the ad? Okay,
no,
cool.
we're good now.
Okay, cool.
Yeah.
So, engineering gets 3 semesters to go through all of calculus, whereas everybody else gets 4. So that makes things a lot harder to
And
do.
the engineers do sequences and induction in
Yeah.
the first
Oh, yeah.
class that the other ones don't.
Well, and
I can tell you the slight difference between
Okay,
the
so I
difference
wanna-
between
here's a-
134, 100, and 114. It's like at the bio.
what's the point of induction?
The point of induction is to have. I don't know why they go to the stairway to heaven all the time. I think my stairway goes the other direction.
Well, that's
But
just a negative sign.
Anytime you have a statement that when you're trying to prove something about an infinite amount of things, so for every integer n, you want a statement that's true
Yeah.
for n.
Yeah.
Then what you have to do is, I don't picture it as either of the stairways. I picture it as a flat dominoes falling. So the scenario is you have an infinite amount of dominoes. Each domino is the statement for the third domino, so it's true. So 2 by 2 matrices, or an and is true if and only if P and Q are true, or both conjuncts are true. But what if you have n conjuncts? Is that true if and only if all of them are true? So now I want to prove it for every n. So what you have to
P1,
do
P2,
is,
P3.
if you can show that this P statement implies the Pn plus 1 statement will be true also. If you can make that proof, that's what you're proving in the inductive hypothesis there.
Yeah.
Then and you can prove that one of the first ones is actually true. So the first domino does fall, and if the nth domino falls, the n plus 1 domino falls, all the statements will be true and they'll all fall. So you're
But-
trying to prove it about an infinite amount of things,
I want you to answer the
which can
question.
come up
that-
in any mathematical subject there is.
Right.
I want you to answer the question, if you can,
They use it for sequence.
without getting into philosophy.
Is there a difference though?
Is the average first-year students can say, why am I learning induction proofs?
Because
engineers?
Because-
the strong law of large numbers, you can have examples to where Fermat numbers, or in the reverse, f, what's fn? This is 2 to the 2 to the n minus 1, I believe. So if you look at f1, this is going to be 2 to the 2, you can do 0 to the 1 minus 1, which is going to be what? Now you have to do the exponential. 2 to the, that's going to be 4 minus 1, which is, a prime number. He sees Fermat.
Mhm.
And so then he says, well, and if you start computing what's f2 now, I'll just start doing it. F2 is going to be 2 to the 2 to the 2 minus 1, which is going to be what? 2 to the 4 minus 1, which is, no, that can't be it. What's the formula?
It's equal to 15.
Yeah, which is composite, so that's not the right definition.
Is it a
Fermat.
plus?
Is it plus 1?
No, it's not plus. Or yes, it is plus.
It is
Because that'll be a
plus.
5 and a 17. Yeah,
Yeah,
so we're
something like
good.
this. So yeah, I had the wrong definition. You gotta
That's all
alter it.
good.
Also, that one shows you that that one would have been composite, so then this will be 17 plus 1.
There you go.
So then when
they
we get
all-
that, Fermat starts doing this, and then you get to a bunch of the numbers, and then you can do this, what's the next one gonna be, 2 to the 2 to the 3, so
So-
8, 2 to the 8, which is 256,
But the question
257 is
is,
a prime number. And then he says,
why?
all these are prime, all these are gonna be prime. And so how do you know out there that there isn't some really large number that breaks the statement? This is what we're trying to
Right.
do. And if you look at F, I think 6 or 7, which is like in the billions or whatever, we
Yeah.
didn't have this in the 1600s. That number is composite. Euler shows it's composite. Clever there, yeah.
So the reason that's hiding there is, so the question is why
Infinity
are they
takes an
only
extremely long
showing
time,
it? But see,
especially
here's the
towards the
thing,
end.
there's lots of different ways to do proofs. There's proof by contradiction, direct
So-
proof, blah, blah, blah.
so
But
if-
why?
if I could chime
The
in.
student wants, I want you to answer this disembodied voice.
Yes.
Why do engineering students learn a proof technique?
So, for one, it shows don't assume anything based on whatever pattern you think you're seeing, right? So if an engineer sees, it looks like this is going to happen, it looks like that is going to happen.
Deductive versus inductive.
Yeah, you want to show those reasoning skills. Hold on, don't assume that it's going to happen just because it looks like it's happening at first, right?
Yeah.
You show that somewhere down the line. things
Since
could-
we're on there, and then in the engineering one, in 100 engineers, I'll focus on this because these will be the meat and potatoes too. They're the strongest ones that are always gonna show up, and it's competitive. So the engineers are going to try to work harder to get all these things and fill in the gaps and all the little clever intellectual things that you learn and steal from another instructor as an advantage that the other people that don't have. So this
Exactly.
does
I've
become a
stolen
commodity.
many
So
things
let's
from
look at this one in the
engineering.
reverse of that. The first one that I showed, Fermat numbers, eventually is not prime. There's one that's composite. So if you said all Fermat numbers are prime, which Fermat did, he's wrong, and you can't just assume that and use inductive. You have to use
The
inductive
trap.
reasoning. But look at this statement now. This one's weird in the other case. There's a really good paper by Richard Guy, who turned 100 in 2016, so I gave a talk about Richard Guy, but he has the paper called The Strong Law of Small Numbers, and he does exactly this where you can.
Nice.
And he says, we prove this by intimidation. I like the guy, so he just gives a bunch of examples as to why this will never work out. But this one's in reverse. If you look at, for every n, if I look at n equals 1, this is not true, because I get 2 to the 1 is less than 2 factorial, which is 2. It's not strictly less. Wrong. If I look at n equals 2, then what do I get? 2 to the 2 is 4, but that's not strictly less than 4 factorial, which is, or sorry,
There's-
2 factorial. Did I do that wrong?
Yeah. Well, if you're using
No, no,
two
Oh,
factorial-
there it is. There's the mistake. 1 factorial, which is 1, which is still wrong. But then this would be 2 factorial, which is 2, and that's wrong. But n equals 3, what do I get? I get 2 to the 3 is 8, which is strictly less than 3 factorial? No,
Just six?
it's
So it's still wrong.
So equals 6, but then when you look at n equals 4, now it's gonna happen, and 2 to the 4 is 16, which is less than 24, which is 4 factorial.
And
So
then
it starts, so it's
5.
false for the first 3, and then it starts to be true, but here's the other thing for the engineers. Why, and then what we will do is prove it by induction, let's do that also. So by induction, what I have to show is, you have to get an n naught now, that was the first case where it starts, so that's my domino now.
Yep.
So the first 3 dominoes were spaced too far apart, they're not gonna play. But now if I take the n equals 4 domino and all the other ones out there, I have to look at the Pn domino hits the P, and it has to be able to hit the Pn plus 1 domino. So this is the base step, or base domino, or patent pending.
That's called base case to everybody
Base
else. but he
case
likes
or
his
base
dominoes.
step for the step to Stairway to Heaven, the base step is what they're talking about. And then the inductive step is going from the step to the step. I don't know why it goes up all the way. So n equals 4 is true, I just showed it, that 4 factorial is 24, which is strictly larger, I flipped it, but that's okay, which is 16, which is 2 to the 4. Now what I want to show is, if Pn is true, I want to show that that shows that Pn plus 1 is true. Because I don't know if that's going to always be true, or what if there's another number where it flips and it stops being true again for some large number out there that I can't conceive of. How do I
Could be.
know that it's not going to
Don't
do that?
assume anything, right?
So, except for in this, you do assume, your inductive hypothesis is, I do assume that the first n is true, and then I have to
So
show that it
IH
shows that the n plus 1 is true. So
inductive
and you have to use it
hypothesis.
somewhere. So what are we assuming? We're assuming this is true. And this is not even the story as to why I'm excited. Where did they get this, and why do they want this to be true? Just a second. So, is this true? I prove that. And then what you always want to do is you want to look at the n plus 1. So this is the n case. I'm assuming this is true. That's what's the n plus 1 case look like? You have to put n plus 1 where n is here. So now I want to show, what do I have? What do I need? Indeed is what we're going to do in a second. That's also the mantra. What do I want to show? That 2 to the n plus 1 is strictly less than n plus 1 factorial. And the Schwartz, the Hermann-Schwartz, and those inequalities, that
Yeah,
book.
the Schwartz, Bunyakovsky, and Cauchy, Schwartz, and
Honestly, Schwartz
Bunyakovsky.
inequalities, they all say that
Yeah.
equality in calculus is easy, it's inequalities that are hard. So now I want
That's
to
true,
show this
actually.
using this. So let's start with that.
And while you're winding up, well, let me just say that in 134 and in Math 144, you will visit inequalities almost always, of course, kind of proc dependent, but in 154, the business calculus, probably not so much, but go.
So now what I want to show is that this is going to be less than the n factorial. And so somewhere in there, in the algebra, what I've just done is in the exponential algebra, I have to find the n plus 1 case in there. I know that this is true for n larger than or equal to 4.
Because we've assumed it.
We've already assumed it a priori as my assumption, and now I want to conclude this, so it has to appear somewhere, and there it is, that's where I'm going to use it.
Yep.
And then now what I'm going to do is, that will be 2 times n factorial. And now what bothers everybody is 2, I know because n is larger than 4, 2 is strictly less than n plus 1. Which is the statement QED. Now we're
That's
done.
the trick right
So
right
the
there.
dirty trick is that
All these
bothers
tricks.
everybody is because it's not equals. I have to say he's less than.
Yes.
So now I've just done it. That proves it. Therefore, Mark would say, therefore, by mathematical induction, this is true for all the steps. But the more important part is, for me, and then you can get weird divisibility tests from this and these types of things too, but
You can only
why do I
steer
care
the-
about, so now why do I go back one more
Yeah.
and care about this statement being true at all? Well, if I flip this, what do I know? If A is less than B, then what about 1 over A and 1 over B? Oh,
Aha, the trick of the
so now
reciprocals.
look, 1 over n factorial is less than 1 over 2 to the n, and then I can power series, and does this converge? Yes, because he's less than the geometric series, but I have to know that that's true for every n, that this works, so that the reciprocation is true, so now I can prove that this power
And if
series
you're
is
wondering
convergent.
why-
And this will happen in 101 for the engineers, so
Second
right
semester
next semester
calculus.
it's gonna happen to
Engineering.
you, so this will all be connected, you're gonna use induction first, but the reason I want it is this statement.
Yep. And there
who's
you go.
this? E.
And I will say, one of the hardest things, before you get to
That's
multivariate
a
calculus and
mic drop
engineering,
right there.
So,
is Math 101.
come to our tutor sessions, shut up for a
Oh,
second.
let me,
I brought the biggest book so you can hit me with it.
that's not as big as the stats book. The,
No, stats is bigger.
one of the
Oh,
hardest things you're
you
gonna
said
learn.
mine's
Would
bigger
you
than
stop
yours.
talking?
Even the mine's bigger than yours.
The,
Chaos.
this happens, we can be sitting around talking about nothing in particular.
Why
It's
won't
the
they
same
give me a
thing.
job? I don't understand.
Thank you, help me
You
get a
see,
job.
they should care about what you just did on the board instead of the
Not about my
periphery, because that was
pedantic
the
attitude, yeah, okay.
Math 101, one of the hardest things you're going to learn in Math 101 is that unending string of questions involving infinite series. I'm just warning you now that January's coming, and that's hard.
There's not one method,
Okay.
there's the test for divergence,
Yeah.
limit
Oh, yeah, there's so
comparison
many
test,
ratio.
alternating series
Yeah.
test, ratio, it's like, why do, because they don't have one that will say, if you do this, then this one will converge, there's a bunch of tests, and it becomes chaos.
Okay.
So I have to say, this dynamic works because we have the
Disembodied voice.
roaring train, steam powering ahead, and then the cool-headed engineer who's like trying to back it off here.
The bridge is out. He'll run over the bridge. I'll stop before the bridge and I'll get out and go, yeah, told you. Okay, let's move to, I'm going to talk extensively about statistics, but I want to make the way through a few other topics first. So if you're here for the statistics discussion, it's coming. Just give me some time. I have to tire him out or I'll never get a word in edgewise. Linear algebra.
Linear algebra.
A student is going to go into Math
Oh.
120 or 125. What should they expect to see? Because back in the day,
It's gonna be
you
worse
used
than
to. I'm not done
calculus.
talking yet. Stop. Back in the day, Math 31 used to have a linear algebra component, and that way you had your feet wet when you ran into this. But you don't anymore, unless you had a really savvy math instructor who actually went against the curriculum and taught you stuff that you weren't supposed to know.
So I think
linear algebra.
Math 35 in high school is now linear algebra.
Oh, okay, that's news to
Yeah,
me. I
yeah,
haven't
that
done
was
high school in a long time.
that was a new one to me too, because
Okay.
I thought it was just 31 was the.
Yeah.
It's like take me to the Greek. It's kind of like calling the jug at Jeffrey's. Like, what'd you call it that? Because Jeffrey's sounds so nice, everyone will take it. And by the time you take it, you're chaos.
Too late.
And so this
Okay.
linear algebra is the Jeffrey of frickin' math
A
classes.
lot of
It
students
should
are
be-
going to, I've
Don't take
experienced this many times, many students say, oh, algebra, I know, I'm good at algebra.
Yeah,
But
I did
linear
the same.
algebra is a big, wet
I thought to
box
myself,
and-
linear, how hard could that be?
It's gonna be violent in here.
I thought you were trying to tire me out.
I want you to, somebody, either one of you two, to describe the syllabus, the course outline for first semester linear algebra and things students need to know. Go.
I vote Adrian.
Here's the working title. It shouldn't be called linear algebra. It was the Jeffrey joke. It should be called
Vector
HSC's
analysis.
determinants and n-dimensional vector spaces. And then don't take it. They don't
Nice.
prep you. K to 12 preps you for calculus, not for linear algebra.
Okay,
and
so,
the half-wits in the
n-dimensional vector spaces.
advisory board doesn't know what they're talking about. And they'll be like, try linear algebra. No, no.
What's a vector?
A geometric vector is a directed line segment between 2 points. It's very geometry. Start learning geometry. First
But
of
it's
all,
gotta
it's
start
not
out
in
of the
K to
origin.
12. I don't care what he's saying. But geometry, it will
Yeah.
save you. Draw a picture is the mantra every damn time. Here's 2 points from one of the axioms, I believe, one of the Euclidean geometry. There's one and only one line segment
Do
between
not
2
go to
points.
non-Euclidean geometry here, please.
No, we'll stay in Euclidean space.
It's his favorite topic, and he'll start talking about it unless I tell him not to, which you'll
But
ignore.
it's so cool. Yeah, that was amazing. Oh my god.
We're not talking about that.
We're
Yeah,
not trying to
yeah.
scare
Octothorpe
students.
is isomorphic to this.
All right,
It's
so
a set of
vectors.
balls.
N-dimensional vector space on the Cartesian
So this is a
plane.
directed line segment, you take 2 points, what's a vector? This is a vector. A vector has both, like I like to say, I'm 6'1", but that's my magnitude. I'm the object, the length of the object. So this is the vector B. The vector B is the directed line segment between 2 points, but it also has a magnitude and it has a direction. This is one direction. The band, didn't he just die in some kind of, they're
So all parallel
they're
vectors.
going 2 directions now. But this is one direction. I don't care whether you're pointed this way or this way. This will be a direction. This is a different direction.
Ah, but if it's 90 degrees, it's orthogonal.
They're
You get to say
orthogonal.
that word a lot.
Yeah,
This
yes.
is how he created the Cartesian plane. He's like, oh, well, I need one, and then if I take one perpendicular, I'll call that the origin, and then you can get a grid from it. And then this is Rene Descartes' Cartesian coordinates.
Okay, here's
That
what,
was
okay,
deep.
I want you to do
I
something.
want to
for me.
extend that to Steiner circles.
Okay, I want you
He knows
to, I
what
want
I'm
you to,
saying.
I want you to do this. You don't have to, because you tend to do what the hell you want anyway. But every
Okay,
student's
no
going to be asked to say, oh, prove that this vector is independent.
The set of vectors is
The set of vectors, sorry, my bad. Prove that a set of vectors is independent.
This one has a conditional in the conditional. So first of all, the vectors, unlike what we were just talking about, even if they're functions, if they're a vector field, it has to have an F on their FU. And if that takes a vector 2, then you know, oh, we're mapping from 3 to 3.
Okay, so if you're in 3 space,
But, and also this should be connected, we're chopping this up so that you can digest it at first. Linear algebra is the tools that I use to do multivariable calculus and single variable.
good point,
What
good
do
point.
you use for a
Math 209 will
straight
hand you
line?
your
I
ass
can use straight
if you
lines
can't do this.
for this, to find the instantaneous rate of change of the nonlinear thing, I use the linear thing. It won't change when I use a surface, I'll use a tangent surface. And then what's this direction? This is a vector, and then this is a vector. And then what am I gonna use? This happens to be a proportion of the partial derivatives in this direction and then in this direction. And what's the area of that parallelogram? The norm of u cross v. And so that area is the temporarily approximation of all the things that we're gonna do in multivariable calculus. So calculus and linear algebra are separated more importantly. What did you ask me? You wanted me to talk about?
The importance of independence.
Oh, linear independence.
Yeah.
So basis is what they're gonna talk about, basis of the space, and what's dimension of a space. Why do I call this 3-dimensional? Why are 2x2 matrices 4-dimensional, Precious? Dimension is the number of vectors in a basis, all right? I want to describe everybody uniquely in a space. So
Okay,
basis-
I just we got a comment here from Godel Glitch. And you
Okay.
should appreciate the name,
Yeah.
Godel.
I'm
Don't get him
pretty sure I
started.
know him, it was one of the
Okay.
students at McEwen.
Okay, so anyway, the comment here is, and this is most apropos too, is I thought linear algebra would be more like regular algebra, but it turned out to involve a lot of geometry and graphical visualization.
Yes.
That's exactly
So
where.
you're, you're saying what I said is they should, it's called a Jeffrey, because
Yeah.
like, and you took it, by the time you were on it, you was too late, and you're like, I don't like this trip, and I'm going home. And yes, it should be called determinants, or, yeah, matrices, determinants, and n-dimensional vector spaces. But why do I want that in any dimension? In a basis, they want these two things. Span will give you even more nightmares. Linear independence, and then spanning. It has to span the space.
Spanning set.
Spanning set, and what do we need to span the space, the basis of, your vector space, but let's call it Rn, so at least we're talking about geometric vectors. You can talk about matrices.
And one thing
et cetera, et
that
cetera.
Disembodied Voice and myself started talking about, and never did finish, was writing a study guide for linear algebra. We
We can
finished
start
that.
Oh, yes,
too.
we gotta,
Yeah,
yeah.
We got about 300
The major
pages or so,
topics.
but,
Yeah.
But spanning, what that does is, it allows you to write everybody in this space as a combination of these vectors. So you're gonna get some, if you want these guys to be a basis, then what that means is, if there's any vector in the space Rn that can be written that, say you take an arbitrary guy, I want to describe it this way, so we're gonna call it alpha 1, x1, not scalar, vector, plus dot dot dot, plus scalar. Oh, I call them x's, now I switch to x.
yeah.
So if I want this to be a basis, these guys, then I need to first be able to take anybody in Rn and write it as a linear combination of them, so I can describe through these guys how I get this, and this is Mark's mantra. The coordinates of this vector in this basis are the linear coefficients of that, so the coordinates of that vector
Is
x
there a
in that
generating
basis
function for those?
of x, and we could probably do that, yes, it's a
Sorry,
truncated.
we've been talking about
That'll be
combinatorics
a
and
different
generating
one,
functions.
generating function, exponential generating function. But this is where this vector gets the coordinates in that basis from, in this one. Normally, when you use this, we're using I and j, so the coordinates are going to be obvious that you went 1 unit out, 1 unit out, and that's, you're already sort of doing that. But I didn't get to linear independence yet. This is span. If it spans the space, every vector in here can be unique, or can be written as this, and then I get I get coordinates of that vector in this basis, a description of it in that space. Linear independence says that this will be a unique description. So linear independence says, but it has a conditional in there. It says if 0 is in the span. So if 0 is written as a linear combination of those vectors.
So can
Yeah.
we say alpha 1 is how many of the x1 directions we need to go? Alpha 2 is
Yes,
how many
that's
of these?
what it's going to break up if you're using the canonical standard basis. But you can, what that's saying is you can use any vectors you want if that's
Right,
your
right.
vector, and any two non-collinear vectors. Now that's going to look. This is why. So what you're saying is this. Well, we'll do the independence. Independence gives you a unique description. So if 0 is in the span of those guys, alpha 1 x1 plus alpha n xn. If 0 is in there, the only way to do that is that all of these guys are zeros.
Go no directions and you're at 0. You're at the
Or
origin.
alpha equals 0. And so why is that called, well, this is a linear equation, first of all. And why do they call it linear independence? Because if it's not, and one of those guys is non-zero, then we could do this magic. I would have that alpha 1 x1 plus up to alpha n minus 1 x n minus 1 plus alpha n, or let's use not n, let's use I, alpha I x I. Let's assume x I is not 0. There's one where I get that 0 guy. My pen's running out, plus blah, blah, blah.
I have lots of pens.
So I'm going to take out this guy, the xi coordinate. He's not 0, so I bring him to the other side and I get negative alpha I xi equals the rest of this guy, everything out of there. So alpha 1 x1 plus whatever I took out plus the alpha and xn.
But
All I did
since
was
alpha
take-
sub I, negative is
But he's
zero,
not
you
0
can
anymore,
divide
so I
by-
check, I can
Yeah.
divide by 0, and that's the point, is negative alpha I. I've now made xi linearly depend on all the other vectors, and I don't want that to happen because then that means that there's more than one way to describe my vectors in space through those guys. So linear independence is actually the parasitic definition of dependence is the thing that I don't want, and we necessitate linear independence. So if this happens, the only way that that can happen for us is if all the coefficients are 0. And then that would tell us, that's why that's hard for your brain also. There's a conditional statement in the conditional. If this conditional happens, then you're linearly independent.
And if you're thinking, I'm never going to take this,
And how do I-
if you, let me interject quickly. If you take second semester statistics, so typically Stat 252, you're going to run into linear combinations as part of figuring out multiple comparison analysis. So
And in
this
that,
is important.
You can give that flow chart in there. Now what I'm going to do is, to be a good pedagogical instructor, I'm going to connect back to day 1. How do I turn this into a homogeneous linear system, which I want non-trivial solutions for? Well, this has a vector, so this is the 0 vector. And then I can write that as equals, and then this is alpha 1 times x1, so then I have x1 to xn, plus dot, 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 yeah. Don't use the black one, or don't use the orange.
Mine are
one.
refillable.
Plus
I don't throw
alpha
mine
n
away.
X, so this would be 1, 1, and 1, and then this, because he has n coordinates, but then now this is xn1 up to xnn. And then if I rephrase that, I get x11, alpha 1 x11 plus dot 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 plus alpha n xn1 equals 0. And then I get a linear system of equations. So day 1 stuff connected to this abstract nonsense. So that'll be the mantra. In this type of scenario, in any linear system, there's one solution, no solution, infinite, many solutions. But in that scenario now, I'm going to ask the question of, are these yes independent or not independent? I'm going to take that horrible abstract definition, turn it into a matrix, an augmented matrix of a homogeneous system, and then when I get to REF, not only do I have to deduce whether there's one solution, no solution, infinitely many, but I have to
What
say
is REF?
answer yes or
What
take
you-
the class and watch our
Yeah, watch
take-
the
watch-
linear
I have a whole
algebra.
playlist of linear algebra up there.
Complete course.
reduced
Yeah.
echelon form for matrices. It's not just about matrices.
Yeah.
It's about this stuff.
It's about this, using
Okay.
matrices
A
as the
system.
tool of the working thing. What does matrix mean? This is the word. Matrix means womb.
So
Mother.
this is, yeah.
Matt is mother, Rix is womb of the beast,
Yeah,
put
but the
together.
root
the
word
womb.
is matrix.
Yeah.
Which if you read Dune, of course, isn't necessarily a good, the honored maidens, no? Okay, let's not, sorry, I gotta stay on topic now.
Did you know that a bridle is the bit that you put for compliance? Just saying, that's what a bridle is on a horse.
Hey.
Bridal
Oh, yeah.
shower.
All right, so that's linear algebra. Since I still got, I haven't burned them out yet.
We
want more
need some more
coffee.
geometry. We need more wizard juice soon.
I need wizard juice.
I know, but you ain't getting any
I
until you
need
talk
crumb
about
juice.
geometry.
I want some crumb juice mixed in my wizard.
Okay,
That's called
geometry.
in Irish.
Geometry. What should an undergrad expect in their first geometry course?
For geometry.
Besides getting a compass.
Yeah, synthetic versus analytic.
So it's going to be
Cool.
synthetic, but it's going to be quasi-synthetic and poop at the U of A. Well, because
Right.
Mark
So,
Solomonovich doesn't like the way that U of A is doing
Do
it.
it.
Take it from Mark Solomonovich. I'll forward you the book. I've got a PDF copy, and I'll ask Mark if I can share it.
If you're wondering
How
who this
about we
Mark
get Mark-
fellow is, it's his mentor.
Dr. Mark
And
Solomonovich.
Mark used, when I took it, we were the guinea pigs, we were the first ones at McEwen that ever offered geometry, and he used Euclid's 13 Elements. I found my geometry notes from then, from like 2002 or 2003. And
So what's
he
the
had,
difference?
He had photocopied the first pages of the Euclid's Elements for us and stuff like that, because he was writing the book at that time. Geometry, you want to know, there's 5 postulates. 4 of them are neutral. This will be neutral geometry. The 5th postulate, P5, is that parallel lines don't intersect in the plane essentially. But 1 is going to be one I just used. There's one and only one straight line between 2 points,
Okay.
et cetera, et cetera. I don't know them all. You're going to make
Oh,
it
damn.
take.
Notes for the
But-
students. Students should be taking notes right now.
Yeah. Notes for the students. And then the interesting one is this, that this is where you would get the non-Euclidean geometries from. But this is the classic, the 5th postulate. How does the 5th postulate said? If you take 2 lines and you take a 3rd line and intersect those 2 lines, so let's call this one L1 and L2, and then you have a 3rd oblique line that cuts them, translates, or is laid upon is the classic terminology. If now and then you get certain, if the interior angles, so these guys, alpha and beta, actually that's technically the measure of those angles. The angles of the objects, the measure is how big they are. But we'll
It's his
conflate
pet
this.
peeve, in case you're wondering.
Yeah, the devil's in the details. We can do the Scottish sheep in a second, but if what the 5th postulate says is if I cut this with the 3rd line, if the interior lines is less than 2 right angles, because they're not even measuring them yet, they just say 2D.
Yep.
They don't know how to measure it in radians or degrees. They just call the right angle a D. And so if alpha plus beta, the measure of those 2 interior angles is less than 2D, then those lines will meet on the side where those angles are less than 2D. And then now there's only 2 cases, because if you look at the flip case of this scenario, what does it actually imply? So this is what's weird, and I can't remember exactly how he phrases them, because then there's immediate consequences of how people interpret the 5th postulate. The 5th postulate actually says, if you have 2 lines in the plane, straight lines in the plane, and you take a 3rd oblique line and lay it onto those guys, or I guess it doesn't have to be oblique, that would be the definition of whether it's perpendicular, but if the interior angle of these 2 guys is less than 2 right angles, then they meet on the side when that happens. But if you look at the other scenario, if you took the 2 interior angles to be larger than that, well, on the other side, they would be less than that, so then that would be the same case, you just reverse. But then what the consequence of this is what everyone would possibly know it as. If you do that and it's not, and it equals 2D, then those lines will never intersect. So what it says is parallel lines don't ever intersect in the plane. And the classic scenario was in neutral geometry, which Mark calls it. You can derive most of the things about what you want in geometry as circles and triangles is what I was trying to say, and this came out. So circles and triangles is basically what you want.
This is what circles and triangles are to you. Yeah.
This would be the tools, lines and points and the definitions, but what the 5th postulate, they tried to prove that this was an independent, but what's beautiful about this is trichotomy now, not dichotomy of numbers. If you have alpha plus beta and you call that, first of all, how that connects is in the theorem. The parallel this postulate is equivalent to, it turns out, that the sum of the interior angles of a right triangle is exactly equal to 2D. Alpha plus beta plus gamma, let's call it S for simplicity, is equal to 2D. The sum of the interior angles in any right triangle in Euclidean geometry, this is the definition of it, which is equivalent to this postulate. These 2 things are the same. So now you can ask yourself, in flat space, this is true, but there's, for any 2 numbers in the real numbers, you have either this is true, or this is true, trichotomy. So now we know that this is Euclidean geometry. This is how we get non-Euclideans from this. If you're larger or less, you're going to get either hyperbolic geometry, which is less than 2 degrees, you get the T and A symbol, or you get why airplanes travel on those guys. This is larger than 2D, and even if you take the great circles, this circle, or this triangle, has 3 right angles.
There we go. Okay. And he
What
left
do you want from
Euclidean
geometry
behind.
in there? Those are the first few postulates, and then what you're gonna do in there is you're gonna use triangles, and you're gonna use circles and statements about triangles and circles, and making them equivalent. Synthetic means that you start with axioms, and then you work bottom up. When I teach the non-Euclidean
Practical
geometry,
advice
you're gonna
then.
go
Here's some
analytic
practical
top-down.
advice. Get a good one. Get a good one of these. Not a
Compass
cheap
straight
one.
edge.
The point better draw blood. And
Technically,
when you use it,
according to Mark,
have something under.
It has to be collapsible.
Stick it in there so it doesn't move around. You know, this
If
is.
you're a traditionalist.
If you get a cheap one of
No,
these,
it's
it's a
modern.
nightmare.
I'm
Get a
gonna
good
borrow
one.
Mark's. He has one for the whiteboard he made.
Why don't
Well,
we just get Dr. Solomonovich to do an entire playlist for us of geometry?
We can try. We better hurry up though,
Oh,
because he's
Tim
over.
Vox
He's
fan is,
retiring and he's moving back to either Russia or he's out.
What?
He's out.
He's leaving?
Yeah. He's out.
Can't blame
So-
him, but he's leaving.
Femvox fan was making a comment here too. One of our regular viewers
Yeah,
is
yeah.
commenting on geometry. Reminds him of a book just reading called The Four Pillars of Geometry by Stilwell. I have a couple of Stilwell
I
books.
think I've heard of that.
Yeah.
I think I heard of that
I
one.
don't have that one though, but anyway, yeah, cool.
I'll send you
Okay,
the one that Solomonovich. I've taken Solomonivich's Euclidean geometry, and I've never even taken it for credit. I sat in it twice just for shits and giggles.
and that's good times, you know. Sometimes you've got
That's a
nothing else to do.
marketable
Go sit into a
Also,
course and watch
why
it.
I brought this, and then you can transition to stats,
Okay,
and I need more.
we're going to
fuel.
get to that in a minute, but I also want to, before you get to that, because it's going to be a natural segue, okay?
I'm
It's
not
a
going to
natural
talk about
segue.
anything in it. The reason why I brought the book was
Well, it's a prop, but hang on. If you're in the Faculty of Education, you're sooner or later going to have to take Math 160 or 260 or both. And 160 is quite a hodgepodge of algebra, as in groups. And you would know that.
yeah.
And I
Finite
think there's
groups.
some combinatorics in there. There's some
Yeah.
geometry in there.
A little bit of everything.
It's a survey course, covers a number of things. And you'll notice I keep trying to hit him in the head with the applied combinatorics book.
Incomplete Block Designs has projective geometries as one of its block designs.
So here's the thing.
Oh, I probably won't show you, but
I know
It's there.
Adrian's background in combinatorics isn't something that like his PhD is in applied
stealing my
mathematics,
thunder.
ODE.
That's why I brought the book. Was what I was.
But
Gonna say.
he's going to be teaching a combinatorics course, and one of the things with graduate studies is you learn how to learn. And that brings us around to a comment, or several comments that are coming from Adrian, about how do you learn how to learn, and how do you learn
And
combinatorics.
that's the confidence. It's probably fairly low at first, and there's a sort of some undescribable, like, where's the boundary of the atmosphere and space of Earth? It's like it's sort
It's
of there, but it's like, how do you
arbitrarily
define
defined,
this?
yeah.
And you have to go from being hopefully humbled and realizing you know nothing in comparison to the people that you're going to rub elbows with. Some of the people here are,
Extremely smart.
just the top dogs of the world. And so you want to take that into perspective and do that, but at some point you have to realize that if you're trying to become that, you have to become that. And so how do you go from having low confidence to high confidence to like, I can be like, that's a calculation error, and you start correcting the book. This is where at Stewart Calculus, you're like, I don't care what it says in the back of the book. I've calculated it 3 times and then I double checked 6 more times. The number's 17, not 16. He's got a typo in there. And then you start learning that you're confident in the things that you're doing. And so why I brought the book was exactly what he's saying. It came across my table to, instead of teaching 2 linear algebra classes and calculus and graph theory, I now get to teach linear algebra, calculus 1, graph theory 350, and combinatorics. So I said, first of all, yes, that's a lot more workload. I've never taught combinatorics before, and I can't speak of the English combinatorial design. And
Well, hold that up so everybody can see
and
it.
it's a week. It's just one of the ones I picked. I have several other ones, but shout out to Roberts and Tessman. And
Homeboys.
I was afforded the opportunity to either say, yes, I'll teach that for the other instructor that doesn't want to do the 8 a.m. class. And I was like, I'm used to it. I don't like 8 a.m. either, or I could say no and shy away from the subject that I'm weak at. And there's several topics in here that I've never taught before, but I'm confident that I've already read them and I've already got my own notes on it. And so the point being is, move yourself out of your comfort zone once in a while. Someone much smarter than me once said, don't just try to strive to be better than your peers. Once in a while, try to strive to be better than yourself and work hard at this. He went to get more coffee. Where's he going?
I don't think he's going to get more coffee. I don't know what he's doing.
Now I just got to fill in the gaps.
And now silence.
And now silence. Now it's a dead zone. He walked away and he's like, I'm going to get something. I don't know what we're supposed to talk
Well,
about.
let's use this now.
He was driving, He was driving in
So we
the
were.
direction.
So you were mentioning the courses that you're teaching now.
Yeah.
You have your Calculus 1, which you've been
Calculus
doing.
1.
But then it's really your linear algebra that's like your baby. That is like,
Yeah, so it's
that's where your
reorganized.
wizardry
Yeah.
shows, right? So now you want it to be called matrices, determinants, and dimensional vector spaces, because this is really the tools. And this is actually how I described it to Siobhan.
Yeah.
This is probably the single most important class, because this is where you learn all the most important tools in a mathematician's toolkit.
And if you're watching this podcast on a Sunday and or taking these types of classes and going more than just the first class
This
to get it
week,
over with, then I would assume that you're interested in the subject somewhat and are going to have to take a lot of these classes. So if you're just doing the one and done, then that's okay. But if you want to take eventually the multivariable calculus, linear algebra is also the most important, because it's the tools that I actually use to do calculus in multi-dimensions or in single dimensions. Straight lines and rectilinear objects are the things that I show instantaneous rate of change of curvilinear objects with. So if I'm looking for derivatives or rates of change in different directions, or any direction I want, I know on the line, all we do is technically
One direction,
The first
opposite.
derivative is actually the rate of change of the function with respect to the horizontal x-axis. But then when you have more than one dimension to go, you have to talk about more than one direction, or than just a directional derivative. So when you start doing these types of things, it's linear algebra that I'm using to describe it all.
And then on that, like, it's so important, the tools you learn are so important that in calculus, where they don't assume that you've taken linear algebra, they go over it all anyways, right? It's several weeks in Calc 3.
Any good multivariable calculus book starts off with chapter 1 being linear algebra.
Exactly, yeah. Yeah. So learn your linear algebra, matrices, determinants, and n-dimensional.
And it's like your
vector
meal on a
spaces.
plate,
Yeah.
but they give them to you in courses, so you don't realize that it was one meal that you were eating. I don't
Exactly.
like it like this.
Here's-
View the subjects as one meal that you're eating and put them all on the same plate and try to find out
I
where
like
the
that.
borders of
You
them
must be
interact.
getting close to lunchtime.
Cooking calculus.
This is
It's like,
our
I need
cooking
more-
with calculus.
This is also important when my stomach
Okay,
is empty.
Tim's gonna do some
talk about stats.
and we're gonna go get some wizardry
Okay.
tool, and
Yeah.
we will return.
The one time I
shortly.
could have stayed and shut up because I don't know anything about stats. Can't know
That's
everything.
okay. Cool. Right. So yeah, I had to. I'm an old man, older than this guy, and
Crap, I'm in the camera.
Father,
Go,
Son,
go,
Holy
go.
Ghost.
get out of here, you bums. So I was. I've got my accumulated lifetime of injuries, so I had to go and get some painkillers. It's like, oh, this is hurting me. Anyway, I like math, and that's not hurting me. So, all right. So, Godell's glitch. I saw that too. I'll mention that to Adrian too. On your comment on the chat. By the way, if anybody's watching this and has first year kind of what do I do about this, that, or the other thing kind of questions, by all means, just put them in the chat. And if you're looking at this later on YouTube, you can always email us. We're quite cool with that. Okay. What about statistics? So typically statistics 151 or 161. So what's the difference between the two courses? Well, there really isn't much of a difference. They're almost exactly the same. 161 is oriented towards business students. 151 is for everybody else. But the most important thing about these two courses is it sets the stage for all the follow-on courses. Believe me, statistics goes from really easy, in my opinion, to quite a bit harder fairly quickly. So you do want to do well in the first semester statistics course. Now, the advice I typically give students when you first sit down in a stats class, and if I'm working with a group of students, I do this. My very first lecture is always, let's get some language out of the way. Let's understand the terminology of the discipline, because it's going to be the language for the next 14 weeks of your life. So, for instance, a good example of this is when your prof is talking about a distribution. Context. If it's a distribution of data, we're talking about describing what's the center and what's the spread. Is it symmetric or not? So in other words, it's describing a pattern. If it's a conversation in the topic of probability, which you will have as part of the curriculum in first semester statistics, and probability is probably the hardest part of the course. A distribution then, when talked about in context of probability, is very similar. What's the most common occurrence? Or what's the most likely event to occur? What is the extreme events? What are the extreme events? So these things all come down to the word pattern. So if you think about that, that's your first easy to understand term. One of the ones that always gets me too is the difference. There's three measures of center that you're going to encounter. Sorry, my mustache seems to be acting up today. It wants to fight me. My mustaches are challenging things to keep under control without wax. There's a glass wall here, and I'm easily distracted by people coming and going. And someone was wondering, why is he doing stuff with his mustache? Mean values are averages. Median values is the exact center. The only time those two things are going to line up is when you have a symmetric distribution. So if you think about the standard normal distribution, your typical bell curve, theoretically the mean and the median are the same, but the median is the value that marks the exact 50-50, 50% below, 50% above. The only time the mean also means that is when it's perfectly symmetrical. So whenever you see reference, and I saw this the other day too on one of the social media sites for the University of Alberta, one of the comments was, well, if you know that the average IQ is such, that means 50% of people are less than 50%. That's only true if it's theoretical. So don't see, there's a piece of information that gets repeated ad nauseum, and it's incorrect. If you have a distribution of measured data, it's never going to be perfectly symmetrical, so the mean will always be pulled towards the tail that has the largest, most influential outliers. And that means the mean, if you have upper outliers, is always numerically larger than the median. And of course the converse is true. If the dominant terms and the outliers are on the smaller side, then the mean gets pulled towards the left tail instead of the right tail. The point is, this is a discussion that's coming up the first week or two of your coursework in statistics, and is a good example of making sure you understand what the terms mean. There's an analogy you can make. If you went to a technical college or if you went to trade school, it's the same thing. You are an apprentice, and before they let you play with the power tools, you make sure you know how to use the hand tools, and you have to know the language of your discipline. So if I was to give you some good advice for statistics, is learn the words. Learn the definitions, learn the meanings, because they're fundamental. Another one that always vexes students is, what is a standard deviation? Well, standard deviation is the square root of variance. And that might sound like I'm nitpicking a little bit, but standard deviation is a little less confusing than the word variance. What's the root word in variance? It's vary. Well, how does the data vary around the mean? if everything is exactly the same, you just don't have a spread of data, you just have a spike where all the observations are identical. So I tell people to understand that variance, and by extension standard deviation, then is a measure of consistency. How consistently close to the average value or the expected value do the data points lie? So come to understand these things. I'm not going to, go into glorious deep detail here. We could do it on the board if I was Adrian, I'd be doing it on the board, but I'm just going to talk to you about it. The idea is come to understand these basic terminologies. In particular for Stat 151, 161, the statistics are called parametric statistics. You work with parameters. Parameters are values that are theoretical. You don't know them unless you measure every member of a population. You don't know what the parameter is, but you can estimate it with the statistic. So in other words, the statistic y bar, the sample mean, provides an estimate for mu, the Greek letter mu, and that's the population parameter. So the idea with statistics is to estimate things that you can't directly measure. This is all going to be spelled out in the first couple of lectures, and then things are just going to keep on cruising at a fairly fast pace. And if you don't have a good understanding of the language of discourse, you're going to have a hard time. I'm not saying it's impossible, I'm just saying you're going to have a hard time, that's all. Now, as far as the Stat 151 and 161 course goes for coursework, the way to learn mathematics and statistics is mathematics is by doing it. So there will be online homework. And you'll generally have unlimited tries at getting the answers. So the idea here is to encourage you to learn by doing. I would suggest that you do that. And a comment I made in our previous stream, and I made earlier in this stream, was if you say, I don't need to do this one, I understand it, that's fine, but you're leaving marks behind. You're leaving part of your percentage score behind. And every time you leave something undone, you're just chipping away at the maximum score you can get in this course. If you're diligent, you can get a good score in this course. You don't have to be a rocket scientist to get a good score. Any of the B's, any of the A's are all doable by most people. If you find yourself that this is a very challenging course, well then settle for a C, but all of this is quite doable. Just don't leave marks behind because, I'll make up for it later, because you never can make up for it later. There are no do-overs. No, that you don't get a do-over. On the midterm and the final exam, that's 80% of your mark, and there are no do-overs. Unless, there's something extremely unusual and you can ask for a rewrite or something, but don't count on that. That's a big mistake to think that that's something that you can pull off. That's your basic last chance. So don't count on that. One moment here, I just want to check my commentary here. What do we have here? So flipping a coin isn't exactly 50-50. Oh, this is from Cybeam64. Hi, Cybeam. So if it's a fair coin, the law of large numbers say with infinite repetitions, the probability will settle down to 50-50. But a trademark of truly random outcomes is clustering. So you might get 10 heads in a row. That's fine. That's actually a characteristic of random values, random events. They do cluster. If someone says, here's a page full of random numbers, I just made them up, and you scan through it and you're looking at it, but I don't see any duplicates. I don't see a string of sixes, or I don't see a string of letter A or something like that. I don't think that's random anymore, because people have a funny idea about what random actually looks like, and random does produce clustering. It's one of the ways to measure the randomness of data is how often clusters appear. Now, if you want to cheat with coins, just to entertain Cybeam64 here, how do you cheat with a coin? I'm not saying this is the only way you can cheat with a coin, but here's one way. If you're running a back alley game, you make a little money on the side, right? So typically, let's call it a token instead of a coin. if you look at a token or a coin edge on, hopefully that's large enough. Actually, let me make this a little bit bigger. I don't, let's do this. So if we say here is edge on view of a coin, you'll notice that the corners I've made explicitly 90 degrees. Now, a well-worn coin, they're not going to be perfectly 90 degrees. So on a well-worn coin, these are probably rounded off, but the point I want to emphasize is that those beveled edges, those rounded edges on that coin are probably equivalent no matter how you look at it. So you have a roughly 50-50% chance of the coin falling this way or the coin falling this way. But if you want to game the system a little bit, you get yourself a piece of sandpaper or a file. You don't want to do this too much, someone will notice. But if I was to increase the bevel on this side, like so, so now when the coin is spinning, as coins tend to do when you throw them onto a hard surface, it's much more likely to fall this way than it will to fall this way, because the bevel here and here is much larger. So this might be a 2/3, 1/3 split now. So that's just one way to, game the system. But a standard coin, though, should be 50-50 in the long term. So on 100 flips of a coin, probably get any kind of probability. Might be 70-30, might be 60-40, might be, it's even plausible to be 90 heads and 10 tails. That's all certainly indicative of a coin. It wouldn't surprise me in the least. But if you had 1,000 or 10,000 flips of a coin, and it's a fair coin, it should be converging to 50% heads and 50% tails through one of the many laws of large numbers. So that's one way to cheat. Dice are easier to cheat with, and of course all games of chance in casinos and things, they watch for this, and they have their own dice. But you can always change the shape of the die by filing or sanding one side. Now it's no longer a perfect cube. As soon as the thing is no longer a perfect cube, now it has a bias, and it's going, and there's another term to come to understand in probability and statistics, is bias. So if you change the shape of the die from perfect cube to some rectangular prism, now you've changed the probabilities of values, and now it's no longer fair. So if you're interested in games of chance, then probably you're going to enjoy, I would hope you're going to enjoy, the probability section. Pardon me, the probability section in the statistics course. Now, what can we say about the rest of the course? Oh, there's labs. There's usually four, because I can't count. This is 4. No, this is 4. There are 4 labs. Software is usually based on R, which is free, and it is a very powerful statistical analysis program. If you're thinking ahead to your future, having skills with R is an item that you can put on your resume, on your curriculum vitae, if you want to go for the CV aspect of it. But being adept with R is a skill that's marketable. Now, R at its fundamental level is a command line program, which most, unless you're already skilled with the command line on computers, it's probably not something you're used to. So the interface that's usually used to that is R Commander, which allows you to point and click. And that's great. Nothing wrong with that. There's a number of other interfaces to R that have advantages and disadvantages. But R Commander is usually the one they supply videos and instructions for on how to do, on how to use. So my advice to you is install R on your laptop right away. It's not a trivial task. Then install R Commander and get that running. If you're having trouble You want to get it sorted out before the first lab is due. It's just smart. Just get it done. Once it's on your machine, it's good there for the semester. It doesn't cost you anything. It's free software. They're back. Okay, where's my coffee, you bums?
I was doing my
Failed venture,
sciatica
everything's
exercise.
closed.
Sciatica exercise.
The coffee shop is closed.
Everything's closed.
Inside.
Stream's
We went to
over.
Hub. We went to Hub and everything was closed.
You bums. Okay.
And I
Darn it.
fear
Anyway, I was-
Subway coffee. I don't know.
No, that's okay. Well, no, but it's sub. There's the Daily Grind.
Everything's closed.
Is
The
it?
only thing open was a Korean place, I think.
Oh, okay.
Yeah, at Hub.
Oh, you guys went to Hub,
Hub.
right?
We didn't
That's
go to-
fine.
yeah,
Oh, okay, that's fine.
We took a chance. Didn't
Okay,
pay off.
cool. So, good eats on campus, by the way. If you're looking for good coffee, that's not Tim Hortons. Undergrind, or the Daily Grind. Sorry, Undergrind used to be in the basement, hence the name. So, in the Student Union building, there's the Daily Grind, and in the new University Commons, they also have a Daily Grind as well. So, and that's Student Union business. So, you're keeping your money at home with that one.
New student commons? Is that the math?
That's where the new math building is
okay.
too. Well, it's not just the math building. Oh, we got Goodell's glitch here too. How much of the mature from stat 151, 150 into 265? Probability theory. I would suggest that,
Be good at calculus.
yeah,
Yeah. For
because all
265?
the, remember with probability, you have function curves and you normalize the area under the curve to be exactly 1. And you can calculate, then you use calculus obviously to find area under the curve. The general version of, where'd my marker go? The general version for this oftentimes looks like an integral where you got x times f of x, because remember we need area dx, this is gonna equal to whatever, right? So there's your template, your basic probability function. Or with more details, e to the negative x squared over 2.
Yeah, you're integrating that curve.
That's
the density.
Ooh, you get the root 2 pi too, right on, that's right. Equals 1. So that's for the standard normal distribution, also, you know, the error function, I guess people call that. And
In my calculus 2-115, which is the transcendental functions after them, I always
yeah.
I make them sketch e to the negative x squared using the steps in the Stewart calculus book.
Yeah.
What's the domain? What's the range?
Yeah.
What's the x and y intercept? What are the horizontal asymptote in the positive negative direction? It has the absolute maximum of 1. I also like this one when we do the comparison test. Oh no, that was the wrong way.
So while you get that set up, I just want to finish my thought a little bit here. So get R set up, get R Commander set up, do the
And
online
then this one
homework,
converges
because
to
the
that one
homework is worth
converges.
10 percentage points. That's 10% of your grade. You can easily get 100%. That's an easy 10 percentage points that, right there. So that means you just need another 40 to pass the course.
Just chat GPT those questions.
Well, when it
Tool,
comes,
not a crutch.
so
Check
the
your
labs,
answer. I've checked my answer with frickin'.
read a book.
I was gone this whole time. You had.
And
your
it was
chance.
enjoyable.
I'm the first person that didn't want to hang out with me. That's right.
That's okay, I don't mind hanging out with you. I did want to say, though, that the labs are group work, and invariably, over the 4 labs, you're going to have an experience where someone's just not going to show up.
Is there a web
But
lab?
just sort of do the best you can. But profs aren't dumb. They know that sometimes group work like that, someone takes advantage of it. There are ways to address that. Your prof will spell out how they want you to do it in the syllabus, and probably discuss it in class as well. Don't be a shrinking violet. If someone is abusing the group work idea by letting you do all the work and then they get their share of the credit, there's a way to address that. Do not let someone run roughshod like that. You just fill out the form as required, send it to your prof. Your prof will deal with it. You don't have to. Anyway, I'm not gonna go into great details about that because that's your prof's job. But I just wanted to point out that if someone's abusing the group work system, the profs know that, and there's a way to address that. Okay, so as far as statistics goes, You're going to, I'm just going to do a quick summary. It's going to start off with descriptive statistics and the general idea of why do we do statistics. And that's going to segue around the midterm into probability. Coming out of probability, you're going to have inferential statistics. This is the skills that you're going to take with you whenever you do other courses where there's research papers. How do you interpret the outcome on a research paper? It's all couched in statistics. You'll be fluent in that when you're done Stat 151, 161. And it's going to wrap up in general, it's going to wrap up with simple linear regression, which lays the groundwork for more regression, including multiple linear regression in second semester stats. Now, whether that's Stat 252 or 265, or if you're in business management science 212. And by the way, if you're in the faculty of business and you see anything labeled management science, it's stats. They just don't call it that.
Yeah, some linear algebra as well.
And some linear algebra.
So
But
just
the point
back-
is, you cannot escape math. Just because management science is another way to say, get your calculator. Ooh, comment. Yes, for stats, calculators are allowed, as long as they're not programmable. That's the TI 83, 84, the CAST systems, because they have the entire course built into it. But I would say get yourself a good calculator with a memory function and some probability functions built into it. TI 30 is the one I usually recommend.
Yeah.
$24 calculator, no problems. If you think you're using your phone on the exam, no, you're not.
So, question with that, you were
Yeah.
mentioning the group work. Is that 151 here at the U of A? Because
Yes.
it's a little different at.
How is it at McEwen?
So, McEwen, you have your lab assignments,
Yeah.
which it's pretty. I don't know if they allow the group work, but when I was helping students, it was
Yep.
always like individual, right? It was never
Yep.
as a group. And there were several of those, not just like 4
Oh, okay.
group.
It might be the numbers game too, and their strategies,
Yeah.
because the U of A is already doing where you might have 300 students in your stupid class.
Well, at the
And
first
McEwen's
semester,
capped-
Stat
McEwen's capped at
151
80
here.
right now, so they might not
Right.
have to transition to working with
There's
theirs.
probably
That's-
1,500 students here doing Stat 151 starting next week. So you got to manage that.
Yeah, of
And
course.
grad students don't have anywhere near enough time to mark 1,500 lab papers. So they take that number, divide by
I
4.
was just talking to, yeah.
And I think I know that person. Looks like
Matthew.
someone I used to work for. Glass walls. I'm easily distracted.
I know more than one statistician that works at both McEwen and U of A, and one of them was saying the benefit of, from his point of view, teaching the 300 student stats classes at the U of A is there's 0 human grading
Yeah.
here at the U of A.
Really?
It's all just either computerized or stack or automatic, true, false, or multiple choice. There's no human grading. It's all just computerized.
Wow.
So
And,
because
that's
they
a good
don't have-
point, because the midterm is 30 multiple choice, the final is 50 multiple choice.
I won't mention names
A
either,
multiple choice for these things?
They're all multiple choice, there's no written response. for
Okay,
stats
yeah,
here.
so at McEwen, it
Just
being
put
like
it
Yeah.
written,
So it's numbers
you
game.
get that feedback and you actually get a feel for doing the stats,
Yeah.
right? I don't know, I mean, that kind of,
There's a certain lady, I think, here at the U of A that pushed a lot of those.
I see.
Just make everything automatic and it'll save you. And yeah, from my point of view, this is why you want a good instructor that's willing
Business
to.
versus teaching, that seems like that's the trade-off here, treating it like
Yeah.
a product versus,
Yeah, and how to be.
did I say that
yeah.
out loud?
You
Oops.
want someone willing, well, yeah.
Well, ultimately, it comes down to who's going to market. Now we're getting into the philosophy and the truth behind
Why they don't let
academia
me teach at the U of
is,
A.
is this. Someone has to mark papers. And if you got 1,500 people taking statistics 151, and back in the day, there would have been that many people anyway, but there was still the hand-in homework. How do you mark that and actually not just rip through it? Oh, right answer. It's,
So also,
it's a
if-
waste of time.
If it takes it, or in your engineering, and it takes them a month to give your midterm back, I'll tell you why.
Because someone's marking it.
Because they're marking them by hand, and I had to mark 1,371 related grades questions over and over and over again, and they made us do this, and then, I won't mention any names, but the coordinator of Math 100 had 3 midterms and a final exam, and they all had to be hand graded, and if you say that it takes you you could do the math, I won't even tell you, someone in the chat tell us later or put it in the comments. If it takes you 2 minutes to mark that question and there's 1,371 students many hours is that? To mark one question.
And how much do grad
It's
students get paid?
over a work week, I'll tell you that in Canada.
And how
It's
much do
over-
grad students get paid?
Paid?
Diddly.
Paid? What's this?
Next to nothing.
What's this
They
pay
give
you
us a
speak
small
of?
stipend and then they garnish you off of the frickin' tuition off of that. So yeah,
Yeah,
I
so
was making
no.
like 18 grand a year for like the whole frickin' thing.
And then they
Peanuts.
were garnishing.
And then I pointed out, yeah, that's the thing why they don't let me work here anymore, I'm pretty sure, is because I said, this is the part of the education process I don't like. If I, as the instructor, don't like classes with 300, and you, as the student, doesn't like the class with 300, who likes it and who's benefiting?
Lorenzo,
We're
come over
in
here.
the money.
This is funny voice.
Hold on, hold
Yeah.
on.
No, I want.
We gotta
I don't
allow
wanna
the
get
stuff
into.
that-
I don't want to get into politics and philosophy, but I want you over here. Come on, come on.
What are we doing?
2/3, 1/3? I'm out.
No, you can get your butt over
I'm
here.
still in here?
Get your butt over here. Okay, okay.
So in Stack, how does
Stop.
Stack know whether this is true or if I put that in and it's gonna say wrong, but it equals 1?
Well, this is.
Some systems are getting better.
Okay, what I wanted to say was, we're gonna wrap this up. This triumvirate of idiocy.
No diggity, no doubt. You gotta bag it up.
We are the Tudor Wizard. Well, it all started with him looking like Gandalf, but I mean, the name is what it is.
Hey, like everything else, I started this
YouTube
goddamn
channel.
company. I'll get no credit at the end. It'll be taken
Our
over by these two
YouTube,
pricks.
our YouTube channel is full of videos
Facts.
on how to do stuff. I do the
Gordon.
statistics, he's got the calculus and linear algebra, Lorenzo's got stuff on there, cooking with calculus.
Yeah, I've been meaning to develop that
Okay.
more. That was posted like 3 years ago, if not more.
Okay, my point is,
I was gonna
on
show
YouTube, here is a free resource that is specific to the University of Alberta and specific to MacEwan. And for that matter, if you're taking calculus, mathematics anywhere in probably Alberta, what we're teaching on our channel is relevant to you. I mean, you can go anywhere you want on YouTube and find math instruction. Fine, knock yourself out. But this is specific. And
We were gonna do that.
we're right here. Oh, you wanted to do something?
No, it's all right. I was just gonna
Yeah.
close it out. But the power series of arc sine is related to this guy, this computation. And we were talking about doing the combinatorics and then stepping yourself out of the probability or 265 step 265. You know what n choose k is when they're all integers. What happens when it's this guy? So Newton defines it as you want to do -0 and then -1/2 minus 1 up to -1/2 minus n minus 1 over n factorial. So this is the definition of a fractional choose. But then how do you turn that hot mess into a nice factorial?
Hot mess is right, too.
Factor out
So what does that become? It becomes -1/2 times -3 over 2 times -5 over 2 times ... Now what's this guy?
Oh,
That's
you don't
the
even
size
have to do that,
calculation.
yeah.
That's -1/2. Oh, I'm out of juice on this.
Oh, here's a good question. Before we wrap up, there's a good question here from Godel Glitch. Wants to know,
Common denominator.
oh, Atom Fighter, oh, we got somebody else new here too. The board is too hard to see, even setting it to 720p. Yeah, I understand, markers and
We
everything.
weren't gonna use it to do
Yeah.
anything.
Yeah, that was just basically there for doodling. So, Atom Fighter,
We'll do that after.
10101, welcome. Yeah, you're not missing anything here. This was just basically background, and of course, when you have math people around and a place to write, things get written.
Yeah. In my
Godel-
basement,
but
when
Godel
we
wants
write
to
in my
know.
basement, it'll be
Yeah.
legible.
Yeah, so we have a
Smells
studio.
like cat piss, but we got a lot of math there.
Shut up. I'm gonna hit him with the book. What is available for? Yeah, I know. It's like the Three Stooges. You know, so look on YouTube. Three Stooges. Look on YouTube.
Stooges math.
Tudor Wizard. No difference. Hiding under here is not much, as far as hair goes. So what's available for summer courses, independent study courses? I think Godel Glitch, you think? He was talking about like independent study math is Math 398. I bet that's a MacEwan course.
I just taught that with Siobhan.
Yeah.
Oh, yeah.
And I just tutored Siobhan with that.
Non-Euclidean geometry, whatever you want as long as you're going to get it approved, but they won't let me do it because I'm a lowly sessional and you have to be a full-time person. So
Well,
I got
we're
my
trying
mentor,
we're
Mark's.
Stop
I'm
talking.
not bitter. I got Mark Solomon.
We want him to get
Add-on.
his tenureship. He's been slaving away far too long and is too darn good at what he does. We want him to get a tenured position at McEwen. I know
Start
he's his
a
own worst
petition.
enemy.
I don't even care at this stage. Please
Yes, you
support
do.
us on Patreon and start doing it. I'm going to build my own institute across the street. Turn up the volume.
Okay,
To 11.
so we're coming up
There you
on 90 minutes of chaotic streaming, but hopefully we've given you some guidelines on successfully navigating the mathematics courses. Nothing is easy. I'm not sitting here, I mean, I think statistics is easy. I think Math 154 is easy, but that's what I think. Your experience is going to be different. But what I'm telling you is you're now learning a topic that is introduction to an entire discipline, and it's worthwhile. You will use it. I don't care what someone says. Oh, I'll never use it again. Yeah, don't
Yeah,
listen to
well,
that
If
person.
you want to
That
get
person doesn't know what the hell they're talking about.
philosophical, yeah, you're at a place and a time on Earth and a place and time in space where you're replicating bags that are aware that you're replicating bags, and you can learn whatever the hell you want. Why would you take any naysayer and shut
Yep.
that down?
Yeah.
Can we end on a Serge Tankian quote?
Yes.
Somewhere between the sacred silence and sleep, disorder, disorder, disorder. Let's organize it.
All right, goodbye, everybody. Thanks for tuning in.